Hey everybody, it's Brad reaching out to you. And as I had just released a video on the test phasing, going through the process of making sure everything was working right and doing everything I needed to do, it came to my attention that I was having some issues on my tiered system. My tiered system is the enterprise core server systems. They relate specifically to my core overhead chassis here with my capacity and my decommissioned 2246, and then my TrueNAS platform here and it's fully operational 2246 down here. So basically two things have happened here. So I've noticed here on my environment that on my TrueNAS environment I have some odd errors going on about transfer sustainment speeds, which means that even though my transfer sustainment speeds should be working correctly, my reporting is not. And I'm trying to understand what's going on there until I finally did realize what was wrong. And that is my core competency server, this guy right here. He is having a problem. And I think it's more significant because I've just noticed here that I'm getting a priority alert on this. So I have two major issues. I can't work on this machine unless I have more capacity, and that capacity can retain and hold everything that matters to me for this machine. But this system is not performing correctly. It's not hitting the bandwidth speeds that I need it to have. I'm sitting on a 10 gigabit switch here, but it's performing more like a half a gig bandwidth, and there's something wrong, something seriously wrong here. And over here, this guy is connected by several other environments. He doesn't have the capacity to take on what's over here, but he can do a few things. So I'm going to have to add, yep, you guessed it, and I bought 10 of them right here. 10 more terabytes of capacity. So what I'm going to do here is I have two issues. One, I have non-compliant 1 terabyte drives in the chassis over here. That's, I think, about 4 or 5 of them. And then I've got my 450s on this, I'm sorry, the 500s on the end. So what my goal is to create another large volume set, decommission these other drives, bring my TrueNAS back up, make sure everything's working correctly, and if it is, I can transfer all of my data from this side down to the 2246, and then I'll buy a new motherboard and I'll rebuild this as a video for you guys later, as you will understand that sometimes OEM chassis like this, which in this case it was a Google search server, sometimes those motherboards can be a little flaky. So what I'm going to do right now is I'm going to go to the TrueNAS platform and decommission my pools and make sure that all disks but the crucial disks are basically addressed. So in here I have, let's see here, right, 16. Okay, so these are my 931 gig drives. I don't want to touch those. And then up here are my 500s. So my 500s are the ones I want to decommission. So I'm going to go here and I'm going to export and disconnect. I'm going to destroy. I'll go ahead and ID the name. I'm going to confirm this, and I'm going to basically wipe out those drives. Now, why am I doing this? Because I need the extra capacity spec in those so that I can do what I need to do. And then, yes, lo and behold, I will have to go through the process of mounting and dismounting disk drives and so on and so on. So with this being done, I will have nothing pretty much but Constellation drives in here. And the way I know that is I've got my 931s here, my SSD drives, yep, only SSD drives. So if I check my disk pools, I have more out there like these guys right here, which are basically Dell these are the 500 gig drives, and I have some other drives in here that are out there not in use, that are basically what we call non-identifiable multi-pathway drives. They're just single pathway drives, and those I'm going to pull out as well. So stand by for a second. Okay, so up here is my powered off chassis. It's basically not doing anything at this point in stage. And then down here, skipping this 3-part, are my disk arrays. And from here, first I want to pull this guy out. These are, I think, 900 gig drives that are not multipathing. And so I'm going to have to check them out separately, find out what's going on with that. And make sure that those drives are addressed. 1, 2, 3, 4, 5. So half of my disks are going to go into here, and then I'm going to have out here the additional disks, which will be handling and working with specifically the formatting of the way I want to expand the disk out in accordance to my requirements. So that being said, I'm going to go ahead and pull these guys out and put them back in, because they did not spin correctly as they should have, and that is a problem. And I'm going to add the additional drives to this equation and get that set up so that we'll be in pretty good shape. Now TrueNAS has got one little pain in the butt about it. I could make a stink about it, but I'm not. And that is the fact that at one time, JBOD, or just a bunch of disks, would allow you to basically go in and configure anything you have and put them in accordance any way you want it. And then they turned around and started doing type class configurations, which basically in a nutshell meant that if they weren't basically the same make and model, they wouldn't bind them together into groups anymore, which sucks. But at the same point in time, on the enterprise side, that is the correct procedure. So you have to pay heed to the fact that if you want all of your ships to go at the same speed in your fleet, then they all need to have the comparable capacity to do that very job. And in too many times has it been discovered that's not been the case. So because of that, the end result is, okay, enough of the drive compatibility mode driving. In other words, you're running in a very basic compatibility mode. You're getting really no performance of any kind because you've mistyped the class of the disk drives, like 5400 RPM versus 7200 RPM is a great example of that, versus 10,000 versus 15,000, and they're all in the same channel. Which, remember that in these designs, these chassis have 3 channels right here, and you'll have a divider inside that actually can show you where those channels are. So that's something to remember when you're dealing with this. So, with that being said, your TrueNAS needs to be scalable, which is nice. It is. I can yank out hard drives and put in new drives and then rescale things. I can readapt the pool sizes to a bigger or more functional size, or in this case, what I'll probably do is go with two 10 terabyte deployments so that I have some flexibility between them and work with them that way. Now I can still, by the way, add a big, huge pile of disks up on the 720 chassis. Now, remember what I told you earlier, that the 720 chassis can do 26 hard drives by themselves. And technically you could put a drive inside the chassis if you wanted to, but it wouldn't be redundant. You could use like an SD card or something like that. But that's not very practical, right? But yes, you could technically fill this all up with disks, and then all of these up with disks, and then this with disks, and you're in pretty good shape. That's actually what's happening on over here. I have disks up here, I have disks in here, and I have disks down here. But the overall function and capacity is kind of a trick, because I don't have 1 terabyte drives in all of these chassis, so I don't get the capacity yield I'd like to get. But I do have what's called performance tiering, also known as HSM, and that allows you to do quite a bit. HSM allows you to basically take different tier levels of disk storage and play them into high performance all the way down to extremely slow performance as archive storage. Same thing as what you would refer to in, I guess you'd call it the classification side of things. For cloud storage, you can have this one capacity that is super cheap. We call it Arctic storage. It's really slow, takes a while, but it will hold your data. So that's where you can spend your money and save money by keeping your costs in check. Now, the other challenge with that is, of course, the fact that you're dealing with a configuration that will not do well for you for things like, databases. So hence the strategy. You would use the database for the database, and that would be high performance capacity like SAS 10,000 or 15,000, or SSD standard or SSD advanced with caching, and that would allow you to do this very thing we're talking about. And but HSM was the solution before clouds brought the same strategy, but in a distributable format. In other words, unlike a HSM storage model like this that you see right in front of you, it's restricted to the local area network that it's confined in. Unlike a cloud HSM solution, which is basically distributable by the cloud itself. And that gives you the secret sauce of site-to-site distribution for high performance tiering, which can go all the way down to very basic tiering as needed. Now, with that being said, the other caveat in this discussion is premised on the fact that you have a challenge here with the fact that when you are building your own local disk capacity and you want to scale your disk pools, you have to make sure that the disk pools are in a ready state. In this case, mine was not, and that was the alert error that I got. It will come up as a disk smart error call, and it will say single disk drive pathing, and you will not be able to take those what appear to be identical hard drives and path them into a storage pool with multi-path disks. So on the TrueNAS menu, when the alert comes up, it will tell you, hey, I've got a problem here. Oh, by the way, it's single pathed, which means there might be a problem with the physical drive itself. And that's why I'm removing these drives, so I can test them, figure out what's going on with them. In worst case scenario, that doesn't mean they're bad. It just means they're not actually able to work effectively on a dual pathway SAS architecture. So what you do in that case is you move them into a RAID configuration, and that's basically the PERC controller in the Dell 720. But I have a dilemma right now, and that is I think my 720, my main 720, which does all my work, all the heavy duty stuff, and it's really nice that one machine can do pretty much everything I need, is exhibiting, I think, IO wait state errors and some conflict configuration errors, and that's got my attention. And so I suspect probably maybe a DIMM issue, and the DIMM is failing to maintain integrity, or I have a logic board issue on the OEM motherboard. and that also can cause some significant issues. And so when IO wait states hit your data write cycle, it's like somebody having hiccups in the middle of a presidential speech, right? The IO wait states interrupt the data state transfers and cause multi-query reprocessing steps, or basically saying, hey, did the packet go over correctly? Oops, I messed up. Did the packet go over correctly? And again, you're just not seeing the sustained bandwidth transfer rates that you were seeing a couple years ago. And I've had these chassis for a while now. A friend of mine, Gary, he gave a whole bunch of this gear to me, which I've used for churches to help them out. And then over time, they'll return the equipment to me as they finally get on their own feet. And then I repurpose them for the next whatever as a goal. But unfortunately, over time, I move them over to IT professional services and things like that, so they can actually have all the value of the latest technology opposed to these older platforms. And then in honor of Gary, I make sure that they're not disposed of, because he's a great guy and he really enjoys doing this stuff too, and having some fun and just keeping the education process going. And that's why I bring these things to you guys, so that you don't have to pay a lot of money for training that you couldn't afford normally, and I can give it to you here. So with that being said, and obviously I'm trying to occupy your time while I'm prepping these drives, but this is a true reality with disks. When you have so many disks, you have so much time that you have to go through to get them operational. So with that being said, the truth of the matter is, as much as we like to play with these environments, they are still just that. They're just environments, right? And it takes time to set them up, take them apart, test, config, set them back up, take them apart again, and so on and so on. So if everything goes right, and I've done this before so many times it's not even funny, when I put these disks back in, as you see I'm doing now, and I hit the power button and bring up my 720, the 720 will hopefully come up, and I will discover new disks. And in that process of discovering new disks, those disks will clear the path failure, and by clearing the path failure, I will have an open register access point where I can begin the process of testing everything out again. Now, with that being said, I have one other tiny little problem, which I'm going to address here in just a second. And that is the fact that I'm going to close the loop here. Give me just a second. Alright. Yep, that did it. Come on. There you go. Now, let me show you what I've done. So now, as you can look, all 24 bays are now one terabyte drives. Now, the last two are blank because I don't have enough disks to populate them, and these 1 terabyte drives I have over here, I don't consider safe. So what I'm going to do for now is I'm going to transfer the 500 gigs. I'm going to put them up here to populate these trays to better make them fit better, keep the airflow under control. I'm going to step away from you on that one so I can get this done real fast, and then we'll resume. Okay, so I moved the 500 gigs up into the Dell chassis to kind of make that airflow work a little bit better. They're not in actively, they're just in to fill up space so that the airflow is flowing the way we need it to flow. Now, the second thing I've done is I went ahead and reparsed, and we're starting the process of booting up the server itself. And that is coming up now, I believe. Hang on a second. Yeah, so we have it posting now. So this will just take a second here. I've got to wait for a minute here. Okay. So we have gone basically back to the setup here, and we are refreshing. I have powered it back up. So with that being said, This test bed is going to come up, and I've blown this away several times already. But we have full population down there. We have all these drives sequestered and set. Everything should be okay. And now I should see what I need to see, and that is going to be here in storage. Go to the pools. First, make sure my current pool, the one that's most important to me, which is this 931 gigs, and then go down here to the disks and make sure that all I am seeing are 931 gig drives. And of course my 8 93 gig drives, which are my high-end flash cards. But I am seeing quite a bit. I go back here to the very beginning. Here you can see the variety of my disks that are out there. And they appear to be showing up correctly. And they're inactive drives, which is good. There's the DASL, which is fine. And if I go back, way back up here to the beginning of number 1, I should be able to go down here to pools, and I should be able to add, and I am going to do this just because I want to do this. I'm going to create, and I'm going to change the state of the drive to a hot swap. Okay. I'm going to add, change the state, add. Alright, so that is for some reason not working right. So let's do this instead. Okay, that is done. Spare VDEV. And that test was successful. Okay, so I know I can do that now. So I'm going to leave the group. Now I'm going to go back and add a new group. I'm going to create a new group. And we are going to hit all the remaining drives. Cannot use numbers at the beginning, because if you do, it will crap out on you. I'm not going to do encryption this time. Going to pull them over. It's wanting to do Z3, which is basically a little too much, so we're going to stick to just Z. That will give me almost not quite 10 terabyte of capacity. Let's just add another one here. There might be a chance that the call CL will, yep, there it is, call CL34. That's not surprising. So I will have to pull these sets out. Still giving me an Operation CLC it, and let's find out why. got a pulse rate. That's not correct. Take you out. Try that again. Okay, so I have an issue going on here specifically with the drive states. That's something I will have to investigate separately, but I should be able to bring these over into the test group, because basically what I need is 2 sets of volumes, not 1. So by making sure that I just have a core base equivalency of a RAID 5 configuration software-wise, I will be able to support the NFS requirements that I need to do for the Proxmox, as well as to set states into play. Now, with that being the case, then I'll go after the remaining disks for grins and just say RAID 1, RAID 1 plus 0. And I will pull these guys in, and I will change them to mirror. Okay, so we're still getting the Colcia error, so let's go to Stripe. And it's okay, I'm going to force it, because I can use this as junk storage. I'm still getting that call error. Okay, so I'm going to have to research that to understand exactly what's happening on that. Formatting attribute aspects are apparently an issue. So if that is the case, then what we will do is we will simply do, we're going to try one disk. I'm going to force it into a striped state. Nope, it cannot be formatted, so that's the problem. Formatting is generating the issue. Now that means I'll have to test each and every one of these to see if they will or can be even forced into a single drive style formatting. Alright, so probably at this point in stage, I'm going to leave these 4 remaining disks alone, and I'll use the other disk capacities for what I need to have done. And I have fixed my biggest problem, which is basically taking out 10 non-functional disks that are not properly pathing. So I need to move those out completely. I'll deal with them in a different way. I'm not too worried about that because I've got plenty of places for disks. But now I have pretty much an entire disk array filled full of one type class. So at that point stage, I'm going to go ahead and do some prep work. I'm also going to do some SAS diagnostics on these disks, because over there I've got those 5 disks that are still left over, and I want to make sure that I tackle them as well. Anyways, when I built that NAS in the video that I did not too long ago, it went pretty seamlessly. I was impressed at how quickly I was able to get to the point of deployable disks, and it was just a little too easy, in my opinion. And I knew that was going to come back and bite me, and it did. When I started reaching out for the NFS capacity, realizing that none of those disks wanted to talk or do anything at all, basically, with anything around them, and they just wanted to be left alone. So this does happen with disks. It's kind of a pain in the butt, and you have to build a chassis, or you can use my trick of a single SAS cable tester to basically force reboot and reformat these drives in a low-level style formatting that kind of cleans up the issue that's going on. Another possibility is these disks are on the edge of collapsing. So that goes back to the mindset that when you buy cheap enterprise disks, understand, buy in bulk, because they've been used. You know, you're getting them cheap. And because you're getting them cheap, you have some overhead. So you gotta pay the piper. Have spare disks, be prepared to work with them, test with them, play with them, do the things you want to do with them. And at the end of the day, you'll get them to work again. Please refer to my other videos in regards to how do you diagnose and reformat disks that are SAS standard, and it will walk you through the 1, 2, 3s. Also remember, if you go the single drive testing strategy, this is important. Yes, I did a video on the SAS connection bridge cable, but you need an LSI SAS SATA controller with an internal SATA bridge cable. And what that looks like basically is the drive will have a SAS interface on the back end. For instance, like right here, it's a straight edge connection. Okay? That straight edge connection will basically only allow a particular type of edge connector to go on it. But it comes off as a SATA cable. Now that's where people make the mistake. They think, oh, cool, I got a SAS connection down to a SATA and I can connect it to my motherboard. No, you can't. What you have to do is the edge connector allows you to connect your ATX power supply and provide you a SATA interface cable that would plug up to a SATA bridge SAS style controller. Most generic common motherboards do not have the ability to interact with a SAS drive. Yes, you asked the question, why does it have a SATA connection on one end? That's because it's looking for a SATA SAS connection head. And that's very easy to do. Look up on the eBay, just type in LSI SAS/SATA, and you'll see the card come up and you'll see the cable set and everything, and it will make perfect sense. Just remember, unless you've got a motherboard that is a server motherboard, and not all of them have SAS controllers on board, that's the only time you could directly connect that SATA bridge cable into a motherboard, and that is because it's a server quality motherboard that has a SAS controller built on board. Yes, they test great, they'll work, you can format the drives, you can do a lot of things. It's not an easy process, but I do show how you can do it as a single process, or you can do it as many disk drives being formatted at once. And at that point stage, I think we're pretty much done with this video. We're able to fix the crisis and get the NAS head stabilized so that I can continue to do one of my next projects, and that is to take out my old 720 chassis and rebuild it. And I will make that as a video for you guys so that you can enjoy that experience. And it will be an experience, by the way. But the whole goal here is that you'll be able to see what it takes to take a server that had an original motherboard, OEM or manufacturer based, and how you can resurrect it, how you can keep all that hardware good to go, how you can recycle all the hardware on the motherboard. Saves a lot of money. You know, $100 motherboard versus several $100s of a new chassis. So with that being said, I am going to let you guys go. I hope you have a blessed week, and God bless. Like if you like the video. Thanks. Bye.